And then blockchain is a program suite. Basically, there are three things. Networking, right? Networking of peer-to-peer node, right? So they work together through APIs. And there is a wallet application. Wallet stores private key and public key pair, and then make transactions and send it out to the internet. And then this blockchain protocol is running on top of running on a node. Basically, collect these transactions, put them into a block, about thousands of them, and then verify each transaction has valid signature in it. And then if there is and then verify if this address has enough fund by looking at the record of the blockchain. And then if there is no problem, they put this transaction into a block. And then what's the last thing the minor node has to do? Put the proof of work and then publishes it. Okay, so that's what it is written here. Okay, so data is a blockchain. Basically, Genesis block is started from, and then there are regular blocks. One block every 10 minutes. Block size is about 10 megabyte, about 1,000 transactions. So one transactions like A to B, some Bitcoin is on the order of a kilobyte. So if you put them, thousands of them, then becomes 1 megabyte. And then protocol is consensus protocol, block header, difficulty level of adjustment. I'll get to this later on. And the mining is get the longest chain first. Get the longest chain first if you want to mine it. And then validate all the transactions in it, signatures and so on, and then balance and so on, right? And then get the transactions from the memory pool of your computer, form a block, run SHA algorithm, secure hash algorithm repeatedly until you hit a good hash, okay? Because it's a random number. And then put the proof into the block header, attach the proved block to the longest chain. You connect your newly created block to the blockchain and make an announcement as soon as possible. Okay, so that's the protocol. And then program suite is written in C++, Python, and so on. In terms of, in Ethereum case, it is written in Go. And if you use Python, you can use Flask to make APIs and so on. In this course, we will be able to deal with Ethereum and Bitcoin and then Python programming based blockchain. So the Python-based blockchain anyone can do. Okay, C++, Go, because the suite is very large, maybe selected. I mean, a couple of you can do, but not all of you. But since we have this program suite available, we will build a test network that we have in our laboratory. I will let you guys to run it, test the APIs. So basically, you should be able to utilize the API, the list of APIs provided by Bitcoin or our own test network protocol and the Ethereum protocol, right? You should be able to at least utilize it. Right? Just like you can use ChatGPT, because you are using API provided by the ChatGPT, OpenAI, right? So we have a suite of API functions. You should be able to utilize it at least, okay? So that's what it is. And then basically there is an internet, and then there is a mobile unit, and then they are connected through URLs, IP addresses in this case. And then each computer has a memory, right? So we call it memory pool. And when the transactions are flooded in the network, is sent to the network, they are just sharing these transactions with each other. They'll just propagate these transactions throughout the whole network. And then these transactions are stored inside the computer memory, and then use the CPU to do what? Hash algorithm or validation, private key, public key, pair computations and so on. And then there are some wallet blockchain and wallet application. And then there are some minor applications. Basically, you need to choose those API, list of APIs, to work as a minor node or some wallet node. So there are, not all of them does the mining. Most of them just use the wallet part, right? Then this node only need to download the wallet part of the program. If you run a full node, which does the mining and block validation and so on, then this full node need to download every blockchain, the whole blockchain, okay, and so on. And then they talk through with each other on top of the internet through APIs. That's the point. API makes the intelligence. And then one node asks for transaction, other node give their transactions, other node asks, give me your blockchain, then these other nodes just share the blockchain to the requester. Okay? So this sharing of data and it makes the blockchain network working together. Okay? All right, so here are blockchain verticals. Basically, it is a P2P network of node, no centralization done. And then the blockchain ledger is left open, so it is a public record. Everybody can see, right? And verify by themselves. And the immutability. Once it is inside the blockchain, you cannot change it easily. Why? Because there were heavy proof of work imposed on each block. If you don't have that, a single computer can do 10 to the 12 hashes per sec. So from first block to the last block, if there were no proof of work imposed on it, can produce the whole blockchain in a split second, right? And then change everything. So POW is a very integral part of this immutability. So once you don't have immutability, POW, you don't have immutability, basically. And then trust, because of this private key, public key system, cryptography, SHA functions, and this mechanism, the blockchain mechanism, give trust people. People use this blockchain with confidence. No one can spend it other than me, because I'm the only one who can spend it, even though it is left open in a public ledger. And then this one means coin, because energy is transformed into coin, right? Energy, somebody spent lots of electric energy to produce new Bitcoin. So Bitcoin has same worth, at least, the amount of energy spent, right? And anonymity. So this part was not covered in this lecture, maybe a little bit. There is a person who can make lots of different public key, private key pairs. So there is an anonymity between address or public key to the person. For example, I can make thousands of different public keys, right? I can use them. Actually, Satoshi Nakamoto recommends, in order to have a higher security for your transactions, you need to create new private key, public key pair per each transaction. You know why? This is a human-made system. if you provide a large number of evidences, that is private transactions given to the address, and if you have a large number of transactions made, that means it will give you a large number of equations you can solve simultaneously, then you can uncover the private key. So if you have a large number of equations, right, for a same variable, which is a private key, you can hack the system. So you need to use with caution, right? That's the recommendation by Satoshi Nakamoto. But many people doesn't do that, right? Just create one single private key, public key pair, and then use repeatedly, right? Because they don't want to be confused. So, but in such a case, there is a risk involved in it. So there is an anonymity between person and the public keys. There is no one-to-one relation. You can create thousands of different private keys, then you can hide your identity. So that's the anonymity part. And then rest of them, you can take a look at it. And then, yeah, I think you guys can read about it. In this course, I'm not going to talk about regulations anymore because there are tons of development in the news, and then you can take a look at that, especially SEC and so on. I will focus more on the technology part this semester. All right, you can take a look at it, and then especially this part, World Economic Forum's forecast on the blockchain. It will be 10% of world GDP by 2027, like that. And then it is getting there year by year. And by that, I will stop right here. I'll see you next time. By the way, Wednesday, you have to submit your homework, right? Yeah, all right. And then